Good morning. It is day six, 11. My bad. Um, I'm very tired. I went to bed at 2 a.m. trying to get this pull request you can see in my browser. If you can see if the quality is good enough. Can I scroll in? I can't. Cheers. Anyways, um, trying to get that pull request together because today that is due, that web programming project. I can actually show you. Where we're at with that. There's still a lot of people that need to um, get their stuff done, but um, what am I in? Good. Neovim. No, not that. I don't want you. I want you. Download CD. This CD backend. Start that up. Start that up. Error on server at instance. Heh. Oh my god. Oh my god. I didn't see the end of the front end. I'm like, why would this not be working? We're good. Okay. Um, Ignore the illegally streamed Cowboys game yesterday. That was a crazy. I don't know if you guys watched that. That Bengals Cowboys game. Oh my god. The whole kick, blocked kick, and then the Cowboys player touches the ball and the Bengals recover it. The Cowboys are so bad. Oh my god. That was crazy. Anyways, this is the site. Again, there's still stuff like this that it's like it's not styled correctly. Why these 3 stars? These aren't my products. This part is beautiful, made by one of my classmates. And so I had to implement. So I have the add to cart, so you can add to cart. And this was what what I made. I hooked up that add to cart and also the buy now button. This UI could be so much better. Um, but then you can proceed to cart with this, and then you can fill out all your information. I like this tab thing. Um, this project though was really nice because beforehand, every time I made web apps, it was always like with like a framework, and so my mind was always like, oh, if you want to work with like a database or like full stack, it has to be with like a framework. Like I never did just plain JS, and for this was all just plain JS, no framework, and so, god damn, just working with like constructors and rendering methods, appending different HTML elements to a container and like rendering that. It just React was like almost abstracted for me because there were so many like for instance like routing you literally just defined a page and then you just like declared that and then you had a function that like it just like rendered that page what you returned. Um, and so while that is the same of what we did here, it had so many like keywords that I could use to get that done. And here it was I just had to do it in raw JS. So yeah, um, hopefully this review stuff gets fixed. There's still some stuff that I definitely could have done in this cart, by the way, because I'm pretty sure if you go here and it says like in stock or whatever, if it was out of stock and you added it to the cart, I have no way of checking if it was in stock. Like didn't add it, so but it's due in 12 hours and I need to study for discrete math and do advent of code. Also, this page just isn't finished. I think there's a PR on it though, so we'll see about that. But I'm happy with this. And by now works perfectly fine as well. So yeah. I think that's about it. Uh, close these. Anyways, so today, what was yesterday? Oh, yesterday I cut the video short, uh, a little abruptly. Apologies. I got up, to go, to go do something, and when I came back, I went to hit the unpause and I hit stop recording. And so the pause, this button is so nice because it just keeps like the same file. Uh, but when you stop recording, I have to put them together. And so with these videos, I just record straight, no editing, and then I just upload the file. And so if I have to put it in a software and then export it, it does all this like video software stuff where it makes the file actually bigger and it takes so much longer to upload it. And so I was like, do I really want to record 40 minutes, the 40 minutes I have left, and then not be able to upload this until 8 p.m. when I get home? Or do I just upload it now? So I just uploaded it then. So Advent of Code yesterday. I have something to talk about on this. First part, first part went flawless. Um, Logic was great. Did it quite fast. I ended up doing the part two off camera, because I actually looked at the Advent of Code like subreddit, and there was a meme I saw on the subreddit. I wonder actually if I don't want day 10. No, no, no. I want day 9. Come on. I'm close. Ah, this is the one. So I looked at this and I'm like, what are they talking about? And so yesterday's Advent of Code, what we were doing is um I had a thing where I'm checking, um where we were going through, and we were checking to find out how long the block size was. I was checking if the first part of this block size, and then I kept checking if it was equal to that number, and then I'd stop. And so I got it working for the example, but the example only dealt with these numbers that were under 10. If it went to 10, it's not matching every number. It's matching the 10, 10 to 10 to 10 to 10, because I mean it was a huge file, so when the indexes climbed, it obviously went to the double digits, and I never accounted for that. So that was my issue yesterday, and so I ended up fixing it, when I got home last night. Um, but but yeah, I can actually show Advent of Code day 9, right? Day 9. Data.py. So this will ended up being. I should actually include my GitHub into my descriptions or whatever. Um, but this was the exact same, formatting. Um, I made this more modular, um, and yeah, instead of obviously what I just said, I was doing pattern matching instead of, single digit. So yeah, um, yeah, that's that. Second second part, I didn't finish, but did later due to index checking going double digit. Okay. And then here I only got to, just straight up didn't do this. So this is what we're going to do today, and then we're going to start reviewing old exams. Um, but plan for deep work number 11. Obviously, Advent of Code day. Now, I will say I saw my YouTube recommended this morning. Some guy I like watching after that I do the Advent of Code, and he usually, like yesterday, it took him like I want to say like 8 minutes. He's a competitive programmer, but it took him like 8 minutes to solve it. And then today, it took him 2 minutes on the first half and 18 seconds on the second. So I wonder if that was just his forte and that's why he got it, or if today's actually easy. I doubt it's the latter. Um, but we'll see. And out of the code day 9, finish reviewing all lectures, start going over old exams. Okay. Okay, yeah, let's get into Advent of Code. Day 10. I actually do have it. Okay. I don't need this. I can CD into the downloads, CD into Advent of Code, CD into day 10, and then do a little echo period. We want our data.text, and we want our day 10.py. Okay. Day 10.txt. Not what I wanted. Day 10.txt. Oh, nope, that is not. It is data.txt for day 10. Day 10, data.txt. Okay, let's go. You all arrive at a lava production facility on a floating island in the sky. Okay. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you as you're about to ask how you can help, the reindeer brings you a blank topographic map. What is about to happen, bruh? Of the surrounding area, your puzzle input. Yeah, I know what a topographic map is, man. Ugh. And looks up at you excitedly. Okay, perhaps you can help fill in the missing hiking trails. The topographic map indicates the height at each position using a scale from lowest to highest. For example, okay, based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible. It has even, gradual uphill slope. Okay. For all practical purposes, this means that the hiking trail is any path that starts at height 0, ends at height 9, and always increases by a height of exactly 1. Hiking trails never include diagonal steps, only up, down, left, or right. Cool. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. A trailhead is any position that starts one or more hiking trails. Wait, a trailhead is a position that starts anywhere. Okay, yeah. Here, these positions will always have a height of 0. Assembling more fragments of pages, you establish that a trailhead score is the number of nine height positions. The single trailhead in the top left corner has a score of 1 because it can reach a single 9. The one at the bottom left. The trailhead has a score of 2. This is the zeros in this. Wait. A trailhead is any position that starts one or more hiking trails. Okay. Here, these positions will always have the height. The positions marked are impassable tiles. To simplify these examples, they do not appear on actual topographic maps. This trailhead has a score of 4 because every 9 is reachable via hiking trail, except the one immediately to the left of the trailhead. Wait. I don't know if I'm picking up what they're putting down here. A score of 4. The score is the number of 9 height positions reachable from that trailhead. So what? You establish that a trailhead score is the number of 9 height positions you can get from that trailhead. So like right here, it's saying that this 4 allows me to get to 1, 2, 3, 4 nines, 5. Every 9 is reachable. This top means 2 trailheads. The trailhead at the top. So this is a 3 and a 7 trailhead, right? The trailhead at the top has a score of 1, while the trailhead at the bottom has a score of 2. Because this one can go back to 9. I don't get how you find a trailhead is any position that starts one or more hiking trails. It's 0. It's 0. Okay. 0 is the trailhead, right? But there's only one trailhead here, so this is probably 2 trailheads. Oh, this isn't a 10. This is a 0. So why can't is there like a cap to this? Why can't both of these just reach every 9? Okay. Considering the trailheads in reading order, they have scores of. Okay, the only thing that I need to ask ChatGPT, and then I need to pause and use the bathroom, is don't give any code or answers other than the one asked. Why is it? I don't get how this is working, sort of. So a trail head is 0, but what are the restraints? From what I read, you can just get to every 9 from 0. But that's not the case. Okay, well, this is generating. I'm going to use the bathroom. I will be right back. Okay, I'm back. Okay. Okay. So the constraints for hiking trail as follows. So start at a 0. Any position on the map at a 0, these are starting points, and at a 9. Yep. The trail. Oh, that's what it. The trail must complete by 1 from 0. Next step must be a position with a height of 1 and 2 so on. Oh, okay, I get it now. I understand it now. Yeah, so from here, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 1 from down there. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 0, 1, 2, 3, 4, 5, 6, 7. And then I can't get up to this 9, but I can get down to that 9. Okay. Actually, this seems it can be really easy. Actually, I have an idea. Give me this block. Except this needs to be moved over. Okay. Day 10 dot pi. Okay, day 10. Wait, advent of code day number 10. Okay, so with open data.txt as a read, not that, do it as file, for line in file, for record in line. I want the map, top map. And for each line will have a temp line, and then we'll do temp line, line dot strip as well, don't forget it. Temp line equals, no, that's not what I want. Actually, what, temp line dot append chord, and then after this temp line, no, top map dot append temp line. Is that it? For line in top map, print off the line. Python day 10.py. Beautiful. Okay. So now the idea here is that I want another like for line in top map, and then for chord in line. If chord equals 0, right? Actually, what I should do, by the way, is do temp line dot append integer chord. And then this way I can just say equal to 0. And then if it's equal to 0, what we want to do is we want to check only, I want to check every position around it, and if it's a 1, then go down that path and see if there's a 2 or a 3. And if not that, then we go back and so we need like a visited, right? We need like from here, there's a 1 here and a 1 here, right? So I want to check, like, okay, does this 1 ever go to a 2? Oh, it does. A 3, a 4, a 5. Okay. Is there a 6? Yeah, there's a 6. Is there a 7? Yeah, there's a 7. There's an 8. And then once I get to a 9, by doing all that, I increment a counter, which will be, yeah. So if the chord is equal to 0, then what do I want to do? I want to check. This needs to be something like, I can't just do if conditions here. So this stops on a 0. By the way, I also I'm going to need some coordinates going. So index line, enumerate, and index chord. Enumerate. So I probably want like a function here, right? That is, it's a searching algorithm. Def search path. And it's going to take in a map, an X into Y. So if the chord equals 0, then I want to call search path with top map, index line, is that an X? That's the Y. Index chord is the X, and index line is the Y. And so this is gonna return a count. So I want um count equals this, and then we're going to have kind of like a global count that is going to be like number num of paths, I guess. And then I want to do num of paths plus equals 0. And at the end, whatever, right? And then this is going to end up returning some variable. And so now we just have to do the search path. And so what this should do is ideally, see, the only problem with this, right, is that this is assuming that search path is going to return every single search path when it won't, right? Actually, no. It should, we should write the function that at this 0, it does that, right? And then it'll move forward afterwards. And then it's like, I don't even need an else here. So it should be at this coordinate, we need to pretty much, we need to search every single path. So my question is this both the same? So both of these lead down here. So if I go like here, like this is 2 paths, right? I'm pretty sure. Because it'll be like a trailhead that, you know. Wait, am I only returning if that one trailhead? Because this is just one trailhead. It's not the amount of path, it's the amount of trailheads, right? Number of heads. I'm pretty sure is actually what I want here. Okay, anyways. So how is this search gonna work? It has to take a coordinate and it has to look if there's a 1 on any direction. So I think all I have to do is I have to do like an index here, or like a counter, right? A counter at 0. And so what this counter is going to do is it's going to be like, okay, I'm going to check. Actually, this should be at 1 because it should be, I'm going to check if a bounds check if there is a left or right. If this is equal to counter, then move to it, right? And so what I want to do is I want to make sure, because let's say like I do find one of these is like the first instance um is equal to 1, but it goes nowhere, but there's another instance of 1. How am I gonna make it so I go back like afterwards? So if it does not return true, right? If it's not returning, um and not only if it does return true, no matter what, I have to go back. So if I find like a 1 and I go off on these coordinates, if at any point it's false, I go back until I've visited every single possible path, right? So I do need like a visited thing, right? Of just, this is really hard coded, But I could say like checked paths equals 4, right? And then I could do if the top map at um yeah, it would be at X. Well, I need to keep okay. This needs to be a loop. My idea here is I'm going to check if the four, things around this is equal to the next thing encounter, right? So if it is, then I'm going to keep going down and incrementing counter. As soon as it's not valid in any direction, right? Then I stop and I go back to the trailhead and I check. And so this was the thing about my checked paths is that just being a variable was I can say like, okay, if to the right is equal to 1, then like set this equal to that and then decrement like checked paths. And so it'll go through the left side like just first. It'll check that first. And then when that stops and it comes back, no, it needs a way not to hit that if condition again. So this will not work. It needs to know, okay, I mean, I can just do like a checked east equals false, a checked west equals false, a checked north equals false. That is checked. And a checked south equals false. Okay, right? Because now this works. I'm sure there's a better way to do this, as always. But um, I can say, okay, if not checked east, right? Um, I'll just do this, whatever. If checked east is equal to false, then we'll check the east. So if map, oh yeah, it was map that I wanted to do. If map, um, I don't know if this is if map T at X, what? Just at X plus. No, this isn't right. This isn't right. No. Because, okay, well, let's say we go east one. Now I have to check again everything, right? So if one is valid, I have to do a recursive loop with this new head. And then what? I mean, checked east is still false. Oh my God. I guess I could. I'm thinking of a recursive thing here. If I set, like, if I do a temp X and Y, right? And let's say I go to the map T1 to the east, and then I recall this function, right? With this as the new trailhead and the counter incremented. And now I'm checking, you know, and now I go through it again and I'm like, oh, whatever is blah, 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 this. And if at any point nothing is equal, if everything equals true and I haven't found that, then I exit the recursion and I either know that that trailhead leaded to the correct path and I return. Well, I wouldn't return yet. No, I would. Oh, return true. And then I can just say if. But so the whole idea here is if this next coordinate, right? Well, this would actually be y if y and x plus 1. But I wanted a temp thing, right? No, no, I can just do this. 1 equal counter. Can counter plus equals 1 and search path map t x plus 1 and y. And so how do I do it so that oh well, what is this? I guess it's like what? So this is going to return true at the end. So if that next one doesn't equal that, I want to return false, right? No, 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 no. Else checked east equals true. Right? I was trying to think how okay. Starting node. If we haven't checked the east, then we want to go through and we want to check if to the east it is equal to the counter, which is at 1 currently. Okay. If it's equal to the counter, then I want to increment the counter. Actually, you know what I should do? Is I should pass through counter. There should be 0, 1. And then when I pass through this, it's counter plus 1. Um, right, so now I go back through this, and nothing has changed except for our node and our counter. And so I say, oh, is checked east is false, right? And so I say if the next thing to the east is equal to the counter, do this. Otherwise, check east equals true, and then we exit this and we go to the next one, right? So we go to the next one, which is just going to be this exact same thing, right? It's going to be just 4 of the exact same things. And then if it gets through all of this, it returns. Yeah. Then checked east, checked west, checked north, checked south. But there needs to be a condition where this goes false, right? There needs to be a condition that it says, okay, if at any point I hit a 9, if at any point I get all the way through and I hit a 9, right? So what? I want to say, like, I guess my first check will be if, oh yeah, I could do that if counter is equal to 9. Or I guess counter would be the next one. So if counter equals 10, return true. Sorry about my dog. Otherwise, if it gets through everything, then return false, right? If the counter is ever equal to 10, it means that we successfully got to a 9 and we recalled with the counter at 10, right? So we have check east, check west, check north, check south. And so checking the south would be y plus 1. Checking north would be y plus 1. No, minus 1, sorry. I thought I messed the other one up. Check west would be x minus 1. There's no way this is working. There's no way. And then at the end, oh shit. At the end of everything, I want to print off number of heads. Before I check this, I need to validate that it is in bound. So I have to say if x plus 1 is greater than, wait, greater than or equal to the length of map T at 0. Then check east equals true. And break. Right? Oh, I never even like if x minus 1 is less than 0. If y minus 1, oh wow, no, this would be x, y minus 1. If y minus 1, x, if y minus 1, y minus 1 would be going north, so it would be if this is ever less than 0. And finally, If going south would be y plus 1. If y plus 1 is equal to the length of that. Okay. Break outside loop. Maybe I don't need these breaks. I think I'm getting an index error. Search path is not defined. Oh. Index out of range. Yeah. Wait, then is it pass? I always mess this up, bro. I always mess this up on my range checking. Ugh. But after this condition, you did not return or exit the function, so the program. Oh, I just have to hit return. I just have to say return, right? I should always do this as well. What that's saying. I did it last week. I don't know why I forgot to do it this week. Let's just put it in the if. Bum. So it's like in the actual if. So on check east. If x plus 1 is less than the length of map T 0 and blah blah blah. Yeah, so I just do this on every single one. If x minus 1 is ever greater than or equal to 0, then we're good. If y minus 1 is greater than or equal to 0, and finally if y plus 1 is ever less than the length of map T, and then bam, 0. Cheers. Okay. If this ever returns true, let me print off counter every time it comes through. How high are we getting? Okay, so it's a little weird that it's coming through as a 10, returning true, but you're telling me you're telling me wait wait. Print here. I'm guessing this will never print. Okay. Um, so there's obviously an issue with this. Uh, again, only answer my direct question. Why is this never triggering, but counter in the function equals 10 a lot? You call the recursive function like this, but you don't return the result of the recursive function, even if counted begins. And the correct way of calling this function is what's happening right now. When counter becomes 10 in one of the recursive calls, it triggers return true from that call. Oh, so if this ever returns true, then this also. Ah, I see. Return. I see. That makes a lot of sense. Is there anything else it wants to say? Return true. Yeah, no, just that. Don't want that. I want this. Invalid syntax. Wait. Oh, it is an if. Cheers. If search path ever all the way comes back after its recursive loop, then return true. Remove these prints. It looked good though. Is that my only print I had? 9. 9 is correct. And so they have scores of 5, 6. What was the scores again? Wait. The trailhead scores the number of 9 height positions reachable from that trailhead via a hiking trail. Oh, so there's 9 trailheads that lead to 9. Oh, so this is the thing of like a trailhead could lead to multiple. So it's a trailhead that leads to 9, but how many 9s does it lead to? Is what it's saying. How would I implement that? It would have to be at that. So right now I'm returning true as soon as I find just like the one occurrence, right? So maybe if it's if counter equals 10, maybe it's as simple as just saying that I do a like, uh, like it's like just a total plus equals 1, right? Total equals 0. No, this will just keep resetting total. I need a total. Or do I? Oh. Okay, what am I trying to do here? I'm trying to say every single time it comes back that we've reached 9, So it's like, so this one can get to a 9 in, no, in 1, 2, 3, 4, 5, 6, 6, 6, 7, 8, 9, 9. So yeah, so it's like this one has 5 different paths that lead to a 9, right? So every single time for the coordinate called, I get to this 10, I want to increase a global, like total variable. So can I not just say a global total? And then down here, and then down here, it's not an if anymore. It's literally, I just call it. Um, you see my dog? You kind of see him. Um, how do I make it so that a global variable total comes up every time we get to 10 on counter? I also need to make sure that so like when I get to 10, as long as I'm not returning true, right? Can I just say return? Is that like valid? Oh, well, I have all these as like, oh, return true, oh, return true. But I just want it for like when I get to like 10, right? No, I'm just returning true every single time. So you just say total equals. I don't think this is gonna work anyways, but and here I say global total. Uh-huh. Total's not defined. Oh, yeah, maybe because I said G total. 81. Okay. Okay. That is not correct. If the counter equals 10, print XY. Why would it be 81? What's the logic here? What is the logic here that I am messing up? I know it's messed up. It has to be. So I'm going through. I call on this head, right? And my goal is to find out how many different paths from this head get to 9 that follow this incremental pattern, right? Incremental pattern is just indexing one by one and going the right, only those, no diagonal. So I wonder. So I'm saying, okay, if, hey bud, I'm saying if the search path, this next one, so I mean, I recursively call this, and I'm returning a true, right? It's more so, I don't want a return true. I want it to like return. Oh my God. What do I want it to return? So I go down this recursive path that it just keeps going until it hits 10, right? Until the counter is 10, meaning it found a successful trail. And so what I want it to do now is say that starting from east was checked, right? So maybe it's not so much I want to say return this as true. It's more so I want to say that checked east equals true because we've now successfully checked that path, but I don't want to return. I don't want to say, oh, yep, that was, that was a good path. It's like, yes, that was a good path, but let's just try this. Let's just try setting this to true and seeing if it gives my desired output. $81 again? Then checked east equals true, meaning we will not check that path again. We will start from a different path. Oh my God. Oh, my brain hurts because even if I checked east all the way, right? And I found something, there could be another east that goes somewhere. I need some help. Okay, true that. Oh shit, my bad. That's interesting though. So then what do these become? Just this? Is that really all these become? I see. Okay. See what this says. Oh, yeah, yeah, yeah. I don't need any of that. Still 81. Global total, blah, blah, blah. If blah, 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 and blah, 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 then blah, 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 blah. I knew this shit was gonna come back. I knew this shit was gonna come back. So how do you visited always like seems so complex in my mind. So I should learn this right now. So where's the visited? Is visited where are you declaring visited? Mark the current position as visited. If none of these hit, then backtrack. Oh wow. So it's saying to pass through a set and simply just say visited.add. I swear this has to be defined somewhere now. Oh, it's passed through. Makes sense. And then if blah 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 blah. If this and x plus 1 y is not in visited, and then all of this with visited, 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 visited. Right. I have to add this to every single one. If x minus 1 and y not in visited, and that if and x y minus 1 not in visited, and that and then if y plus 1 x sorry x, y plus 1 is not in visited. This is not visited. Is visited. Okay. My bad. 42. What do you mean 42? What do you mean 42? How do I even debug this? Like, oh. How do I even debug this? There's just so much recursion going on here, bro. Oh my god. Maybe? Here. Let's just try it. Oh, that's the one I want. I'm like, no way it got worse as I took that one. That's crazy. Use a path matrix. Bro, why are these all worse than my implementation? Oh, wait. No, I think I was copying it correctly, but yeah. Oh, free me, bro. Free me. What is going on? See, the problem is with like my last logic was that like look here. Let's just go back to here. That I check a bounds and I check to make sure the next thing is what's in counter, right? And at the end of all this, I check if whatever path I randomly went down and I first checked, if that is in, if I got to 9, and if so, then I return, right? But like I don't want to return. I'm busting out O1. Okay. Given my current approach and the question, fix my approach and tell me why. I assume I need a sort of visited tracker because even if I find a 9 down the right side of the trailhead, there could be another 9 down that side, but need to make sure I find it and not re-record the old path code. Right. I did that club tonight. Okay. In current approach, you're performing a depth first search procedure, exploring all possible hiking trails from 0 positions. Uh, Prevent infinite loops, redundant searches. Without a visited set, you could revisit the same position again and again, even if there's no cycle of increments. Yep. Ensuring unique paths and correct counting. You want to count how many distinct 9 endpoints you can reach from a trailhead 0 if you want to keep searching from scratch without tracking visited positions. You might overcount, miss some paths because of infinite recursion. Um, a local visited set versus for every. Okay. So if we've reached counter, we found a valid path. Yeah, I already have that. And then explore the 4 directions. Yeah. 4 dx, dy in directions. And x equals x plus dx, y. Okay, so it's whatever recursion point we're at plus these directions to whatever value. And then bounds checking. If the map at these new coordinates is equal to the counter, meaning that we're a valid step up, and these are not in our already visited, then we want to add it to our visited. We want to search the path with recursion, and we want to remove it after. Okay, yeah. So visited is equal to a set. Is this? I mean, but like, is this not? Um, the really cool thing actually is how condensed this is. I really like this. This is actually a really, really cool like defining directions. Like actually in phone call coming in, I need to go answer that. Uh back. Bu- 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 bum. Pray to the gods this works. I don't believe it. What is happening? Why is it just 81 after 81? Okay. I am running the code on this example and getting 81. Why? Excuse me. So for example, when start exploring from a trailhead, reachable nines. So what here? Okay. And then here, instead of incrementing this, I add this to reachable nines. Print reachable nines. Search path 65% of 6 were given. Oh, yeah. My bad, OG. Oh shit, my bad. Okay, but I get this. It should be for that first 0. I can get to a 9 5 different ways using 70% of the same path multiple times, which makes me think that the visited needs to be different because even though we visited, we can go back, just not the same way. So just marking XY, consider the current counter 2. One way to track visited states. Yes, but you could still get to X, Y counter for 6 moves. Then on the 7th, it deviates. So even that can be revisited. It could be the exact same path for 8 moves, but there's 2 nines at the end. I just want to figure out how to like in my mind. I know exactly what I want to do. I don't know the fucking syntax for this shit, bro. I don't actually know how to flesh that out. But like, how would you even do this without being like infinite, right? And not being so like okay, let's say you'd have to search the entire path, right? And let's say you got to a 9 there. You'd have to search for the entire path again and then like backtrack one and like you'd have to go through every single one and exhaustively search everything and check for every single path that could lead for a 9. I mean, it has to be like it has to be like something where it like goes and it gets this one, right? And then you just count that last one as visited. So it goes to this and then it goes to the 8 and it's like, "Oh, can't go anywhere from that 8." So then it takes the 8 off. Then it goes to the 7. Oh, it can't go this way. It goes to the 7. And so then from this one, it's like, "Oh, from this 8 can I go anywhere?" And then it keeps it like it goes out, comes back a little, comes out, comes out, until it goes all the way back to that first starting node, right? What's this even mean? Check if we've already computed. If we've already computed, it like, okay, let's try it out, shall we? Number of heads and totals, fuck them. Memo added in, baby. 36. Okay, what the fuck is this code doing? God, this dog, bruh. Okay. Exact same thing, total score, enumerating through. If the value is equal to 0, then we call then reachable nines equal to find reachable nines. And then the total score plus equals the length of all the reachable nines. Okay? Understand this. So what's the actual logic here? If the height equals 10, return this. That is a reachable 9 position. Okay? If we've already computed x and y at height, if this is in that, then I return. I don't get that part. Reachable set for this exact same thing. If this is equal to the height. What the fuck is this operator? What the fuck? Okay. Okay. A better approach. Create a function that returns a set of all of this. If height equals 10, yeah. Before exploring neighbors, check if you've already computed find reachable nines at that. If yes, return the cache result immediately. This means if you arrive at this from a different path later, you'll just reuse the result without recomputing. I don't get that part. I mean, I think actually this is exactly what I was talking about earlier. Once you compute all the reachable endpoints, you know all future calls that arrive at will yield the same set of reachable endpoints. You do not need to explore it again or worry about missing alternative routes. This is my only thing, though, okay? This is my only thing. The only thing I don't get here is the memo stuff. If you get to the same point, you just return. What if you got to XY height and it was a value of 8? Then to the east was a 9, and to the south was also a 9. What then? Doesn't just store a single path or a single result. For a given state, we first explore a given index and height. You try all possible neighbors that can follow from this stage and merge. After you combine them all, you store that combination set in the memory. Suppose there's a cell, height is a cell with height on the current path, and you're looking for cells with. You're looking all for there. Some might not lead anywhere, either out of bounds, other direction might lead to another immediate step or directly. For each valid direction, you call recursively. Each recursive call returns a set of reachable 9 positions from that point. You then union all of these only after you've explored all possible directions and combine all reachable endpoints. When you return the same on a later call, if you arrive at this again, maybe through a different path that converges at this point, you don't need to re-explore. Oh, I see. So it's like if I went to a different path, like a different 0, I'm pretty sure it's saying, and I got to the same point, it'll show me all the paths from this point. Okay. Okay. Bro, I fucking hate when this happens. Oh my god, bro. Okay. Um, I mean, again, I mean, my first approach was just wrong. Like, I'll admit that. It was just wrong. And then, I mean, like, I got to the visited thing. It's just like, I don't know, bro. Oh, this is a union. A, B, C, D, F. So this just, that combines. That also combines. Okay, that's cool. Yeah, I mean, I need to start incorporating this. Like when I'm traversing stuff, I just need to make a directions thing. So that way I can just loop through X and Y in directions and then just apply these to every X and Y instead of doing four for loops that I keep doing for stuff like this. That's my biggest takeaway. I'm still like fuzzy on the whole memory dictionary. Let me ask it, can you give a step by step visual of how it's working? Beautiful. Okay. We're looking for a height of 1. We're looking in all 4 directions. We call this because we found this. Now we look for this. Suppose height of 2. We now call 2 recursive calls. We call these. Still no memory used yet. We're just going deeper. Yeah. Okay, now imagine we finish exploring in all sentence. After exploring all neighbors, we end up the set all reachable 9s. Let's say there's found 2 reachable 9 tiles. We now know that find reachable returns this and this. We store this in the memory. When we go back up a step, we also explore. Suppose after full returns to here, we store. Say on a different path. Okay, I see. I see. You union everything that you found, and then later on, if you're on a different path and you find the same one again, it's already in memory, so you know right away if it's going to lead to a 9 or not, so you don't have to recompute it. Smart. Okay, part 2. Reindeer spent a few minutes reviewing your hiking trail map before realizing something. Disappearing for a few minutes and finally returning. Yeah, another slightly charred piece of paper. The picture describes a second way of measuring a trailhead called its rating. Trailhead rating is the number of distinct hiking trails which begin at that trailhead. Bro, it is so cold in this fucking room. Um, a trailhead's rating is the number of distinct hiking trails which begin at the trailhead. For example, the above map is a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails which begin at that position. We already did that. Here's a map containing a single trailhead with a rating 13. I'm sorry, what's changing here? Was that not what we were already doing? Oh my god. Oh my god. Oh my god. If this works, this is gonna be the funniest fucking shit ever. I doubt this will ever work in a million fucking years. But that is the result I was getting with my old code. I mean, right? That was. I just need to. I mean, I know that was what I was day 10. Fuck. All right, let me go to this one. This isn't gonna work. That is fucking hilarious. That my fucking flawed ass approach. My fucking flawed ass approach from beforehand. Oh my god, that is the funniest thing. What? That is insane. I think actually like my original code, like the one that I did when I first asked it for like help. Um like this. Oh my god. That's insane. Why? Wait. Oh my god. So beforehand, number of distinct hiking trails, and then the one beforehand was what was it? It was that the score is the number of nine height positions reachable. I don't get it still. The fucking the score is the number of ways you can get to a position, right? Consider so the it's how many ways I can get somewhere. And so this one was the amount of distinct ways, meaning like exhaustively searching every single one, right? Oh my God, I still don't get it. That is the funniest thing ever. That the method that I was going for earlier to solve part one was wrong on part one because I wasn't like keeping track of already visited like places because it just exhaustively went everywhere. I still like because right here I'm saying that if we ever find this, then go next. Literally go next. So like once I find oh my god, it's just because of the recursion. That's why. It's because the recursion is hitting the counter equals 10 and so total and so I add one to the total. But my only thing is that it's like so I come back, right? I won't lie. In what world is this not an infinite loop? In what world? Why is this not an infinite loop? Okay. That was actually a stupid question. I know why it's not an infinite loop. Why is it then that I get a result of 81 when it seems, I mean, it has to be inside the recursive calls we're adding. I still don't, yes. Yeah. I'm sorry, I'm not talking. I'm amazed that that I don't understand how this is actually working, but I coded it out. I mean, like without ChatGPT's help, I literally coded this out before I asked it for anything, and this was the answer to part two. And I still don't get how it's fucking working. Because at first in my mind, it was like, oh, I do a recursive call and keep I just keep checking everything over and over and over and over and over again. But now it's saying like once I got to 10, it would, go back to its last call at 9 and it would check so it's like it's literally doing exactly what it's supposed to be doing, but that wasn't my intention. My intention was literally it would find like the path of 10 and then it would return everything. So on its first instance of finding that, it would just say, "Oh, we found a path." But no, it's finding every single path with recursion because it's returning its last call. So when I get to that return, it's not just running away. It's like, nope, I'm returning back to my last call, right? And then I'm running through this again. But then that's crazy how it's not like how is it that if it's going back to that last call and it's checking all these positions again, it's not just going right back to that call again because it's like, oh, the counters like, oh my god. I'm a genius on accident, bruh. The loop starts with mhm. Call one is paused. So it goes down its calls and it comes back and then it checks if there's anything. So like at this zero. Wait, so if it goes back to say call one, I'm so stupid. It's just like any fucking function. If you hit an if statement and it's like function. If this equals 0, increment this. Let me just do something real quick. CD, excuse me, downloads. Echo. Actually, was it? Test.py. Huh? Oh, I need to be NeoVim. Um, echo test.py. Okay. Actually, I don't even know why I did this. I can literally do this. Python definition test. Okay. In test, I can say if true, print hello. I still need something to like like I was gonna do. I mean, just if now I just call test. Whoa. Oh, this isn't getting my point across. But the whole point is that if none of the if conditions, if all the if conditions have been checked, right, and all of them get checked, then it just stops the function because there's nothing, there's no loop, there's no nothing here. It's not that it's hitting a return value, it's just done, right? With that coordinate, it checked from, it said, okay, is there a next value equal to this, right? In the east. If there's nothing in the east, then it goes to the west. If there is, then it does this deep recursion of checking everything, right? And then moving back and then checking and checking and checking. My only thing, the only thing I don't understand now is still how part one and part two are different. I still don't get it. I still don't get how this is the distinct, right? I would assume this is how many ways from 0 you can get to every single 9. And the other one would be the same, right? Okay, so this code works for part 2, but I had to create a set logic for part um, I also should do what I saw that guy do. Def part 1. Oh wait, no. Um, that's def part 1, and then def part 2. Um, Um, I can just do this, right? I mean, total in this. Oh, need to go there. But do I need number of heads? I don't think I actually use this. Um, True that. Oh, total's not defined. Where? Heh. The fuck you mean total's not defined? What do you actually mean total is not defined? Okay. Part 1 requires a set to avoid counting the same X and Y position multiple times because we only care about the number of unique. But that's not true. Do you understand what I'm saying here? Like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's overlap here, right? So they're not distinct. I guess it's distinct from the trailhead. Okay, there's 5 here, right? I'd assume 1, 2, 3, 4. So this is 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 2, 3, 4, 5. Okay, but then why is it? Well, that's 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. I didn't count that one before. So like I don't understand what's the difference here. Wait, really? I have to define it up here? 11 and 7. Cheers. Total is not defined. How is this 11 and fucking 7? I don't get it. I don't get it. But then if I go here and I save and I do this, then it's gonna be perfect. But then if I do a def part 2, right? By the way, there's definitely a Vim bind just to tab all this in that I should, probably know. Cheers. Okay, cheers. It might be overwriting values or not, or not. Okay. Oh, except this is actually the wrong way around. This is part one. And this is two. Did I do numerical or yeah? Oh my god. Okay. Get status. Get commit day 10 solutions. Get push origin main. Okay. I mean, I definitely learned. This is actually it probably is the day I've learned the most, especially about like recursion. Um, and how to walk through an array a lot better. And I mean that's the point of this, right? I'm not going for fucking for times this year. I'm not going for leaderboard status. God, this guy got. Oh no, he's first overall. What about today? Who got first? No idea. Eh. What was my personal time today? Yeah, not the best. It could have been so much better. Um, if I just understood part one more. Um, Also, it's kind of ass that they have it based off of like your time from midnight. I don't know why. I don't know why they like the leaderboards encouraged for like midnight. It should just be, oh no, actually this is how you have to do it. Because if it was during the day, someone could easily just look up. Someone could do it, get the answer, have all the code ready, or no, just have the answers ready and you go in and bop bop and be done. So I'm dumb. You wouldn't do that. Well, what only took me 2 hours? Pfft, easy. Okay, now it's time for the fun old discrete mathematics. I'm definitely gonna take a like lunch break soon. Um, I'm gonna check Discord for my web programming to make sure no one needs anything of me, and then I'll be back so we can start going over those lectures. So yeah, give me 1 second. All right, I'm back. I pulled up actually am I oh, I'm not on the right. Move to that. There we go. I pulled up a this video so we can watch how this guy got this done in like fucking 4 minutes max. I hate this guy's like he needs to make this stuff bigger, but I don't know.
All right, we're back for another day of Advent of Code, day 10. Here we go. Okay, it's a grid with a bunch of numbers. It's a topographic map, so I think these are elevations, trailheads. The scores are, are there dots? There's no dots here. We're marking out a trail. Okay, I should just read from the beginning. The height, yep, okay. Good hiking trail as long as possible and has an even gradual uphill slope. Any path starts at 0, at 9, always increases by 1. Okay. Any position that starts one or more trails scores the number of 9 height positions from that trailhead via a hiking trail. Okay. So we have a grid.
Wait, I need to add something to make sure that I get done. Actually, let me just do this one by one. Finish reviewing all lectures. Do the quiz for 250. Do review old homework. Okay, dog.
Do
and range.
So I think what we're gonna do is we're just gonna DFS out.
Bro, could someone tell him? Oh my god, that's literally what I did. This is so fucking funny. Everyone today just made the same mistake of solving part 2 first. That's funny. That's funny.
I think we do 4 adjacencies. We can't go diagonal, I assume. Hopefully. Anyways, and then the DFS is just going to be recursive and return the number of good paths. Okay. If let's do SGPCX. Shoot. Okay. And then if
my god, that guy
the elevation, let's also do
bro, it's like I cannot read this, man. It's like I can kind of make out little numbers. But...
okay. Yeah. And then if g of nx and y, cx cy, then we can go there. If otherwise we do this.
Yeah.
Then if we can't, yep, okay, this looks good.
DFS. Oh, it's a def DSS. I didn't see that he made a function. I'm like, where's his recursion?
We should. Do we need to add things to a scene set? I don't think we actually do need to add them to a scene set. Okay. Sum of scores of all trailheads. I think it's just going to be IJ. Nope. What did I do wrong? Oh, height 0. Ah, shoot. That was... Oh, that's terrible. If this is actually the answer, I guess I can test on the sample input while I'm working on this. Sample input I get 81. That's not right anyways. Okay.
Yeah. Let's see if he fucking says it here, because I still have confused.
Oh, I think I do need a scene set, right? Or no?
Oh, a scene set. That's what he's been saying. Yes,
never include diagonal steps. Okay, we got that. Number of 9 height positions. Oh, I see. That is technically different. Okay.
Wow. So my answers are pretty much just the same logic as his. He's doing the exact same thing of doing a recursive definition of stepping through every single possible you know, recursive depth or whatever. And then he's also, and now he's doing a scene set. But his first one, it's literally the exact same stuff I did. I mean, obviously the syntax is different here. He's doing it with a lot of just for loops, which
So I think in
100
that
is
case, if
it's pretty much the same.
CSCY in scene return 0, otherwise, yeah, because we will export it. Otherwise, we're gonna add it,
So you know, add that.
and then if it's equal to 9, then I think we're fine, right? 737, rank 200. Okay. And now it's asking rating, number of distinct hiking trails which begin at that trailhead. Okay. I think now we just get rid of the scene set, right? Hopefully. I think that was my earlier answer. Rank 94. I got some points. Oh, cool. Nice. It's not many points, but it's a few points. Yeah. Having written that bug and then quickly being, because I had written that bug, I could very quickly realize how to modify my code to like reintroduce the bug to get the part 2. That's really funny that my answer to part 1 was the answer to part 2.
Yeah, it's funny that I did the exact same thing and everyone fucking else did. Again, and I mean, even yesterday, it was like the biggest battle was like figuring out the wording. Like, I wonder, like, on this advent of code thing, I'm sure that's like the complaints of today again. Yeah, it's literally this. Yeah, that's funny that everyone kind of
Coach, and then
together. Oh, okay. Discrete math time. I have the rest of today, all of tomorrow, and most of Thursday to get ready for this exam. So I gotta get going. I'm gonna check one thing before I start, which is turning up the fucking heat in this house because I'm freezing. Yeah, I'm back. I actually just had to shut my door. I forgot. My PC heats my room so well, but when I have my door open, because I had it open for my dog, um, it gets so cold in here. So I just have to wait for it to warm up. But oh yeah, plan for the rest of this is going to be to just go over. I think I'm going to do this um on the recording, and then I'm going to stop recording, go get something to eat, and do this by myself tonight. So, um, because then again, the series is just coding every day, so technically I could just stop it right now and do this all off of camera, but makes the videos longer. And I'm more focused when I'm recording because I know like I mean it's a really low chance anyone is actually watching at this point right now. Um, but if they are watching, there's the chance someone is watching right now, so it like keeps me like focused so I don't just go off and do something random. So, anyways, dashboard. Uh, uh, uh. Yeah, this is due in 10 hours. Oh my God. It's due in 10 hours and the authentication is still not in main. Yes. I'm not changing my code. My code's done. They can do, I mean, they need to commit my code, but anyways, 250 lecture notes. Pull up Notion. Mm-mm-mm-mm-mm. Mathematics. Discrete mathematics. Section 3. Okay. Yeah, I defined all these, and then I did this while I was in lecture yesterday, because this was lecture yesterday. It was talking about like Turing machines, and you can like pass a Turing machine into a Turing machine as long as it's like a string and validity on stuff like that. I don't fucking know. Uh, I never even looked at Turing machines, and I barely even know the fucking what definite state automata, whatever the fuck DFA is. Anyways, 32. Give this to chat GPT. Um, do the same, but for these lecture slides. Okay. Oh, there's one thing I need to order something off Amazon real quick, for my project. Okay. Don't look at the time. I may have just done some Christmas shopping because I got distracted. My bad. I had to buy more female to female, male to female, male to male, fucking breadboard. What do they call them? They call them something weird. Breadboard, jumper wires, I think. Yeah, jumper wires. So I had to buy 10 a 10 one because we get these kits, right? We get these kits in the class uh that we use to work with the Arduino Nano that he gives us. And so there's this little rainbow cable of male to male. And by accident, because I have my own jumper wires from a kit I bought a while ago, I thought the one that he gave us was the one I had. And so I started peeling the wires off because they come as like a 10 like a ribbon cable or whatever, so they're all together. And I started ripping it apart, and before I knew it, I just ripped apart the thing he gave us. So I had to buy a new one to put it in the kit. And then I bought I think like 40 pin connectors of both male to male, female to female, and male to female. So yeah, because I need all of those, a lot of them for this project. So yeah. Oh, bro, this exam's gonna be the death of me. It's worth like 40% of our grade, and I did not do good this semester on like a lot of the stuff. So it's like my grade right now is mid, so this is just like a make or break. Either I'm gonna get like a B or like a C minus, which is horrible. Like I need at least a C in this class. Every other class is an A. This class though, I'm so behind in this fucking class that it's like I don't know, like I'll do as much as I can over these next 3 days, but it's like I think they give a grade calculator, um, and I need like a 40, which 40 that should be easy. It should be easy, right? But as you can see, I'm not even through the lectures and the finals in fucking 450 hours, something like that. So we'll see. We'll see what I can do. On to lecture 32. Okay. We already saw this stuff. Using internal strings. If we know that two strings U and V are L, what is L distinguishable? Wow. It brings this up to a PDF. Let be any language. Two strings U and V are other string. If there exists a string W such that U times W is in L and VW is in L, they are L equivalent. If for every string W, UW in L. Oh. They're L equivalent if a string W times U is in L, and then V times W is in L, and then they're L inequivalent if that's not the case. Okay. Oh, one of okay. Okay, I got it now. If a definite finite automata takes both U and V to the same state. By the way, I need to I hate having sometimes it just recommends just fucking wild shit. I need to take that off. Oh, guys, look who it is. It's me. Anyways, DFA discrete math.
Hello everyone, welcome to the next lecture in Theory of Computation, and in this lecture we will be seeing an example about our DFA or deterministic finite automata. We shall be seeing how to design a particular DFA in this example. Alright, so let's get started. Okay, so we have an example here which is a language L1 which is a set of all strings that starts with 0. L1 is a language which is a set of all strings that starts with 0, and we need to design a deterministic finite automata or DFA for this language L1. So let's see how we can do that. But before starting that, let us see what will be the elements in this set. Now since this is a set of all strings that starts with 0, the elements in this set would be like 0, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 0, 0, 0, and so on. This is actually an infinite set because any string that starts with 0 is present in this language L1. Okay, now let's see how we can design the DFA for this. So, whenever you start a DFA, you should always start with a state, which is my initial state or start state. So I
Mm-hmm.
already told you in the previous lecture that whenever you see an arrow coming from nowhere pointing to a state, that shows that that is the starting state. So A is my starting state. So I'm starting with A. Now, if I get input 0 in A, what will happen? And if I get input 1 in A, what will happen? Let's see what should we do. Suppose I get input 0 in this A, I send it to another state which I call B. Okay? And I put a double circle around this B.
Because that's the
Now,
final
what is the meaning of this
state.
double circle? Double circle means this is the final state. When you see a double circle, it always means that this is the final state. Now, when I give input 0 to A, it goes to B. Now, why is that? That is because I am to design a DFA that accepts all string that starts with 0. So A is my starting state and I'm getting input 0. That means 0 is the first digit. And when 0 is the first digit, it goes to B. B, which is the final state. And whenever a string reaches the final state, that means that string is accepted. And whenever a string does not reach the final state, that means it is rejected. So whenever I'm starting with 0, it should reach the final state because it should be accepted. Why? Because I am to design
Oh yeah, yes, I
outputs
get it.
0 or 1. I'll give a self loop here and I'll write 0 or 1. So what does this mean? This means that after reaching this final state B, whatever input you get after that, whether it is 0 or 1, it stays in the final state B itself. Okay, because the string started from 0 and our only condition is that it should start with 0. So it starts with 0 and after it reaches the final state, whether it is 0 or 1, it doesn't matter. It stays in the final state and that string will be accepted. Okay, I hope that was clear.
Mm-hmm.
And now, is this complete? No, this DFA is not complete. Why? Because we already mentioned what will happen if A gets the input 0, but we did not mention what will happen if A gets the input 1. So A is my starting state, and if I get input 1, that means 1 is the first digit. And should that be accepted or not? No, it should not be accepted. I should accept only those strings which start with 0. So if it starts with 1, what will happen? I'll send it to another state which I call state C. Okay, I send it to another state called state C when the input is 1. When the input is 1, it goes to state C, and in state C, after reaching state C, whatever input I get in state C, it stays in state C itself, whether it is 0 or 1. Okay,
Mm-hmm.
so if a string starts with 1, this is my starting state. If it starts with 1, it goes to state C, and 1 it's state anymore. Okay, it cannot go to this final state anymore. So this kind of state
Dead
or
state.
trap state, because once you okay, so now my DFA is complete because I've already mentioned in A if there is DFA is complete. To see if this is now, let us check if this is correct. Let us take a few two examples to check else my initial A goes and right
This
to
is the only
these
example.
and it goes what is in output state, and this when this string started with 0.
No, nice.
A quick note before we get started. I will use the term machine and automaton interchangeably. They do mean the same thing, and the plural of automaton is automata. A finite state machine, also known as a finite automaton, is the simplest computational model we can construct. It has extremely limited memory, but it can still do many things, and these machines are actually very often used in our everyday devices. For example, the controller for switching an oven on or off is a finite state machine. This controller will have two states, on and off. Let's say this oven is brand new, so it first starts in the off state. Whichever state we start in is called the start state, and we have a little arrow
That's a good way of
pointing
thinking about
at
it.
it. Now, when the button controlling the controller is pressed,
Gets a
it goes
1.
into the on state, and if the button is pressed again, it goes back into the off state. Pretty simple, right? So let's build on that understanding and construct a slightly more exciting machine. Let's construct a machine that takes in a string of weather data as input and tells us whether a heat wave occurred in a given year. In India, the India Meteorological Department considers it a heat wave if the maximum temperatures reach 45 degrees Celsius for 2 consecutive days. So using this definition of a heat wave, let's construct our machine. Let's say this is our start state, and we're just going to call it Q0.
Mm-hmm.
If we hit a day where the temperature is over 45 degrees, we transition into this new state which we will call Q1. And if we hit another day where the temperature is over 45 degrees, we transition into this other state which we will call Q2. Since a heat wave is defined as having 2 consecutive days with temperatures over 45 degrees, then when we reach Q2, we know that a heat wave had indeed occurred. So we call Q2 an accept state, and to represent the accept state, we draw another circle around Q2. And now to complete our machine, going back to our start state Q0, if the temperature is not over 45 degrees, we will remain in the same state. And if we are in state Q1 and the next temperature red drops below 45 degrees, then we will go back to our start state Q0, because for it to be considered a heat wave, temperatures must be over 45 degrees for 2 days in a row. And if we are already in our accept state Q2, we don't have to go anywhere because a heat wave has already occurred. And finally, we'll just modify our machine a little bit more, and let's use a 1 to represent a day with a temperature over 45 degrees, and we use 0 to represent a day with a temperature less than 45 degrees. And there we have it. Our finite automaton, which we will now call M, will tell us if a heat wave had occurred. Notice that the automaton will enter the accept state if it takes in any string containing 2 consecutive 1s as input. All these strings that eventually arrive at one of the machine's accept states are a part of the language of the machine. So the language of this machine is the set of all strings containing 2 consecutive 1s. We say that the automaton recognizes this language, and it accepts all the strings in the language and rejects those that are not in the language.
That's
so
cool.
M accepts 1, 1, 1, 1, 0, 0, 1, 1, 0, and so on. This kind of automaton is called a deterministic finite automaton, or DFA for short. They are called deterministic because for every symbol of an input string read, we will always know what the next state will be. The next state is determined. What we have here is a state diagram of the DFA, and to formally define DFAs, we use a 5-tuple. Q is a finite set of the machine states, and for our machine M, that would be the set containing Q0, Q1, and Q2. Sigma is a finite set called the alphabet, which are the kinds of symbols that are recognized by the machine. So in this case, it is the set containing 1 and 0. Delta is the transition function which tells us where states transition to given an input symbol. For example, Q0 transitions to state Q1 when it reads a 1,
that's what
and
this
remains
is.
in Q0 when it reads a 0. Q1 transitions to Q2 on a 1.
It's just the
and back to
table that at
Q1
each state, given an input, where will we go?
on a 0, and when we reach Q2, we will always remain in Q2.
Usually on exams, I'll say this, usually on exams, I wait until the day before to study, and then I'm like, wow, I really wish I just gave myself a week. And I'm kind of in this point where this is, at least I have like 3 days, is what I'm looking at. I'm hoping by tomorrow morning I'll have that same realization that I usually have, but I'll have a full day to capitalize on that. And then I'll have the exam day to get even more ready. So, um, yeah.
Q0 is the start state. And finally, F is a set of accept states, also known as final states sometimes, which in this case would just be the set containing Q2. One final note on finite automata: a language is also a regular language if it is recognized by some finite automaton. So the language containing all the strings with 2 consecutive 1s is a regular language, since we had constructed an automaton that recognizes it. Now that was quite a bit of information, so let's just summarize what was said in this video. 1. DFAs are 5 tuples that can be represented with state diagrams. 2. If the last symbol of an input string causes the machine to be in an accept state, then the machine accepts the string. 3. The language of a machine is a set of all strings it accepts. And finally, a language recognized by some finite automaton is called a regular language. I will now leave you with all this to digest.
Thank you. Au revoir. Okay. In the same state. So if at here, right? If at I. No, it's not at. I don't know. So the DFA is wrong for L. So in an L distinguishable, I don't think it's this one, right? Because this is saying, this means if you multiply a given string by a given string, it's in L. And so if L, or here in this case, if X is the language that contains all strings, an even number of A's, right? Then it has to be it has to be like, actually, maybe it is C. I think it's C or D. Oh my God. So it has to be even versus odd. Oh, it's an or. So one has to be right, one has to be wrong. I see. I see. I see. I see. I was thinking of like concatenation or some shit. I don't know why I was thinking that. Undistinguishable streams. We use this fact to prove a lower bound on the number of states in a DFA for L. Suppose we can find a set S of K strings that are pairwise L distinguishable. Then it's impossible to have a DFA with fewer than K states to have L as its language. If F is an if S is an infinite set of parallel strings, no pair DFA for L can exist at all. I see. So there's no pair if L distinguishable that can fit in a DFA that's infinite. Wouldn't that also be finite? Is it possible? The language parent has such an infinite set L because if I equals J, then I don't know, bro. Like when you're just giving me a fucking slide of just fucking text that is saying, let this be the language, let's get this and this of this set and this and this and this and plug it in here and then add these together and then set it through the DFA. I can't visualize this. This is my problem with this class, is it's like I like watching these videos and where like I don't know, in which it like defines everything visually and like is like showing it sending around and stuff. But at the same time, no, because I'm the same way with code. Like today, in the advent of code, like I wanted a visual example of how the recursion was actually working, and then I understood it. Um, God damn. You know what? I'm gonna do this. I'm gonna ask it to summarize all of these, and then I'm just gonna go through all of these summaries. Because I don't have time for this. It's going to be, I am a very, very, very visual learner. Okay. I'm a very visual learner. I'll read this, sure. I'll read all of this and I'll go through and I'll try to get a general understanding of everything. But I need to actually be doing these examples and like working through problems because just reading all this, I don't get it. So you know something that'd be really cool? That AI, maybe you could put something together, is something like this, is a visualizing tool, right? Like if I gave it like text, right? For instance, like this. Or for instance, this whole prime thing it's trying to put together. No, it's like, I don't understand what it's trying to say. Visualize it for me, right? And then it makes like an actual step-by-step visualization or a video. That would be fucking cool. Maybe that'll be a personal project that I'll bang my head over because that doesn't exist and I'm sure someone has tried that has a lot more materials and brain power than me. But I feel like that would revolutionize teaching. Actually, you know what? I'm putting that in my notes. I'll just explore it. See if I can find anything with it over winter break. Make an AI tool to visualize any type of math or code, honestly. Math or code. I'm gonna use the bathroom real quick. I'll be right back. Uh, I'm back. My dog is behind me. And actually, I think I'm going to end because I was thinking about it, and this is gonna be so boring. I'm literally just going to be prompting ChatGPT for a short, condensed version of the slides, pasting it in, and then just reading through it, and then just looking at YouTube videos. No one wants to fucking watch that. So I'm going to end it here. Um, but I was thinking about the idea I had. I actually really want to go with it because even if I fail, I think I'll learn a lot. And I was even thinking, I was like, okay, I know, like, I can ask ChatGPT on my own to visualize something, and it'll like print out like something, and I can ask it to like ASCII stuff, right? I could definitely do like an ASCII to like graphics conversion, um, to like, look how cute my dog is. Look at him. Anyways, I can do like a like an ASCII to graphics conversion thing. And then there's something, I think there's really something there. I think like a really simple like text box of like you put in what you want and then I have the model fine tuned to only producing a visual output and then converting that visual output of what they want. I'd have to define the user parameters pretty well though. I don't think it can just be an open prompt fully. I think it's like you have to clearly define this. You have to clearly give like the example or something. I don't know. There's a lot to flesh out there, but I think that's a great project idea that I want to work on over winter break because I know it would be a fucking great tool for me. At the end of the day, I'd probably try to market it, but if it didn't go anywhere, I would love it. I would love to be able to go to my math slides and be like, I don't get what this discrete math, section is talking about. Can you visualize it with an example? And then I'll give it an example and it'll visualize everything that's happening. Um, yeah. And then yeah, I think that's it. So, um, let me just let's go through can I control Z this? Sick. Um, I want to go through Oh, you know, I should. Oh, this is good. This is good clickbait, actually. Right? Extend the camera a bit so you see the dog. And then pull up admin of code. Right, right. I'm crafting here. Let me cook. Let me cook. Gotta look good for the thumbnail. Dog in frame. Okay. You like that? You like that? Dog thumbnail? Okay. Anyways, let's wrap this up. Day 10. Weird day. Also. Logic for part 2 I did by myself. Worked well. Did it for part 1 originally. That is not how you spell that, is it, chat? Whoa, I did it so. Wait. Or originally. 2 L's? 2 L's. Okay. Did it for myself originally. Learned how to go through 2D array better. Define directions. Loop through them with a delta difference. And learned visited tracking. Finish doing this off screen. Will get it done. And then this and this. Yeah. Okay. So I will see you for day 12 tomorrow. Day before exam, and then day 13, day of exam. I will be on here cranking it out. Not like that though. Anyways, yeah. That's it. Bye.